On today's episode, the truth about that United jet engine failure. Today's episode of End of the Line is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.tv today. Even in the age of COVID, well, there's little that the media loves more than the crash of an airliner. Well, that didn't happen to Flight United 238, a 777-200 flying from Denver to Honolulu on February 20th. Put simply, the number 2 or right engine suffered a failure of a fan blade, which parted with sufficient force to damage the engine cowling, which subsequently separated and fell in pieces onto a Denver suburb. Now, the aircraft returned safely to Denver. While the National Transportation Safety Board has of course not released a finding yet, they have revealed that their initial examination shows 2 fractured fan blades, one near the blade root and an adjacent one broken about mid-span. A fragment of one blade is embedded in the engine containment ring. All other fan blades also show damage to the tips and leading edges, which is not unexpected given the high-energy shrapnel bouncing around inside the cowling. The engine manufacturer Pratt & Whitney has announced that an FAA directive to inspect fan blades on the Pratt & Whitney 4000 112-inch engines has been issued, and that the blades will be shipped to the manufacturer for inspection. The 112-inch fan variant of the engine was developed specifically for the Boeing 777 and is used exclusively on those aircraft. Pratt will use thermal acoustic imaging to inspect the blades. The TAI, that's a proprietary inspection process developed by Pratt & Whitney, and it's an interesting technology. Put simply, sound waves are used to excite the part, and the microscopic motion between the 2 faying surfaces at a discontinuity, such as a crack, creates frictional heating, which is detected by a thermal sensor. This triggers further NDT using other technologies such as X-rays. Traditional crack detection technology using fluorescent dye penetrance or magnetic fields, they work, but the titanium blades in those big fans are hollow, with a complex internal shape. And the thermal acoustic technology was developed to create a faster, lower-cost inspection system. Now, what's especially interesting about this to me is that the FAA has mandated TAI inspection of existing blades, despite the process being unique to Pratt & Whitney, and not in widespread use by other manufacturers. Now, what caused the failures? Well, at this point we don't know, but prior blade failures in this engine were attributed to metal fatigue, with at least one blade showing metal shot entrapped inside one of the blade cavities. Now, those of you out there who use shop peening for stress relief know how hard it can be to get the media out of complex shapes. So what happens now? 125 aircraft worldwide are grounded, with 52 in the US, all operated by United. What's the key takeaway? A large turbofan through a blade with enough force to destroy the engine and blow the complete cowling and thrust reverser assembly off the nacelle. Yet the aircraft landed safely with no visible damage to wing leading edges or flaps. The aircraft was never out of control and it flew well in one engine. Just as importantly, no fragments pierced the cabin. The standard inspection cycle for this engine was 6,500 cycles, and at this point the NTSB mandated inspections appear to be a one-off to uncover manufacturing defects. But this incident has thrown a spotlight on Pratt's proprietary inspection technology, and it might be worth licensing and installing this in other FAA-approved repair facilities for other engines as well. Well, that's it for today's episode of End of the Line, brought to you by Engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For deeper engineering content, visit Engineering.tv for exclusive shows like Manufacturing the Future, not found here on our YouTube channel. Thanks for watching.